Okay guys, we are ready for the next section, which is going to be 1.10. And so I'm going to give you a moment to try this warm up. If you didn't do that with me in class, I'll give you the answers and then I'll go through the work and then we will start the lesson. The lesson's actually on 1.10, so I'm going to flip over to that lesson once we get this done. So again, pause the video, go through those, and then come back and check your answers. So your answer should be that the vertical asymptote is x equals -4. There is no horizontal asymptote. And the slant asymptote is y equals 3x plus 1. So if you got those, then you might go ahead and fast forward and check out 1.10 notes. Get started on that. If you didn't get that, we'll go through it. So vertical asymptote, we're setting the denominator equal to 0. Horizontal asymptote, we're comparing the degrees, so 2 and 1, 2 is greater than 1 by 1. Or again, if we take 3x squared and divide it by x, we get 3x. So since there is an x in it, that tells me that we don't have a horizontal, but we have a slant. So we can use long or synthetic. I would again choose synthetic in this case. So we're going to bring down the 3, we're going to multiply, we're going to add and multiply. Again, the remainder is not necessary. It tells us something about the graph. So we have a constant of 1 and we have an x term of 3. So y equals 3x plus 1. You can also do long division for that. So that's how we're getting the slant or oblique asymptote. Okay, so 1.10 today we're going to be talking about modeling with functions. So looking at those notes, we're going to be looking at word problems and how we can construct functions from a verbal description, and then also how to construct functions from formulas. Not going to look as much at that, but I'm looking at the verbal descriptions for sure. So the first one, I really want you, as we're thinking through these few examples, you will need a calculator or Desmos to help you out here, but we're going to look at 3 examples. So as we're looking here, I'm going to do 4 examples in the notes here, but we're not going to cover the 4th example for this particular year. Actually, I may just even cut it out. I'm not even going to do it at all. So if this is a year other than 2020, then I'll have to add on example 4. So we have an open box here with a square base. It's going to be made from a square piece of cardboard that's 20 inches on a side by cutting out a square from each corner and turning up the sides. Guys, if we were in class, I would actually take a square and I would cut out the corners and then fold them. Okay, so I'll kind of show you on this diagram, but you're folding it on these lines. And so your base ends up being here in the middle, and each of these ends up being a side. So think about an open box here. So these would all be sides. I'm going to erase this in just a moment, but I want you to kind of visualize what's going on. So if you need me to kind of visualize that with you, we can definitely do that in a meet as we look at it. So it says express the volume V of the box as a function of the length X of the side of the square cut from each corner. So what we want to do is we want to recognize that these squares are X by X. Okay, these corners here, X by X, all of these. And also remember that it told us that the entire length of this is 20 inches. And that's the same as the width. It's a square. So if it's square, then its length and width are the same. So if we want to find volume, we want to remember that volume of a box, of a rectangular prism, is length times width times height. So the length of this box is going to be, I'm going to highlight it here. The length of the box is going to be inside those squares that we cut out. Because remember when I was drawing this in, okay, the base is actually going to be right here. That's going to be the length of my box. So what I have is I have 20 total. So I'm going to do V equals. And it's actually going to be V in terms of X. It says as a function of X is going to be my length. So it's going to be 20 total, but I'm subtracting an X from each side. So that's going to be 20 minus 2X. Because I'm taking 20, the entire length. Okay, I'll try to show you this with some color. So the entire length, that's 20, but I'm taking off this part and I'm taking off this part. So I'm left with just what I have in between. I'm left with the yellow part. Okay, so that's my length. My width is going to be the same thing because my width is up and down. Again, it's 20 total, but I'm subtracting off 2X. So think about if X was 1, you'd be subtracting off 1 from each side, so you'd be subtracting off 2. If x was 2, you'd be subtracting off 2 from each side. 2 times 2 is 4. If x was 3, you'd be subtracting off 2 times 3, which is 6. Okay? And then my height, remember I said that the height is what we're folding up. If you remember, I said that this was going to be a side. So if I fold that bottom up on that dashed line, the height is actually x. So I'm going to put that in front. Now, if you want to, you can rewrite this because you have the x out front, but then the 20 minus 2x is repeated. It's repeated twice, so you could say that it's squared. Okay, either of these would be acceptable for the volume as a function of the length x. So then it wants us to find and interpret v of 1 and v of 2. So all we're doing is we're subbing in a 1 to this equation. So I'm going to sub it into the bottom one. So I have x is 1, and then I have 20 minus 2 times 1, and then that's going to be squared. So I have 1 times 20 minus 2 squared, which is 1 times 18 squared, and 18 squared is 324. So v of 1 is 324. So we found it. It says interpret it. So what this is saying, remember x is the length of the side. So remember x is 1 here. So if we cut out, the length of the side would be 1 inch squares here. It's supposed to be an apostrophe for inch there. Let me try that again. We're going to cut out 1 inch squares. So if we cut out 1 inch squares, the volume is going to be 324 inches cubed. Remember, volume is cubic inches. Length times width times height. You're multiplying inches 3 times. So then it wants us to interpret v of 2. So you guys should be able to do that. You're going to do the same thing we did with v of 1. You're just going to sub in a 2. So use your calculator there. You type that in, you should be getting 512. So if we interpret that, now we're cutting out 2 inch squares. So 2 inches from each corner. So if we do that, the volume is going to equal 512 inches cubed. So the next question is going to ask for the domain, and then it's going to ask for you to sketch a graph of this. So I'm going to show you, I'm going to come back to part B in a moment because I'm going to show you how you can also use your calculator to help you with this. So we go to the next one. We're going to find the domain, and then we're going to sketch a graph of this. So to find the domain, if we think about this graph, this is a polynomial. So we think that the domain is from negative to positive infinity. But I want you to think about up here, if we started cutting out these x's, if we started cutting out bigger x's from each corner, remember they're going to be the same size. There's only so much we can cut out that would make sense in this problem. So if you think about, if I just keep cutting out and they keep getting bigger and bigger and bigger, eventually I'm going to cut them out to where I cut everything out. Okay, and that would be half of the length and half of the width. So I'm only going to be able to cut out up to 10 inches before everything's going to be gone and I'm no longer going to have a piece of paper or a piece of cardboard. Okay, so my domain here, again, we're talking about x. X would have to be only up to 10. Now, it can't be negative either, and it can't be 0. If I cut nothing out, I still have a piece of cardboard. So my domain is going to be from 0 to 10. And that's because we're talking about a word problem, so we're applying this to the real world. Now, I'm going to show you how that shows up on the graph. So as we sketch this, the expectation for your sketch is we're going to put our x and y axis. So I'm going to put x, and then I'm going to put v of x. We don't have y, we're using v of x. And we're going to put kind of what our window is here. Okay, and I'm going to help you with that. So we're going to take our calculator out. I'm going to first do this on a graphing calculator so you can kind of see traditionally how this would look. So we're going to type in our equation. So we have x times 20 minus 2x, and you can either repeat that or square it. So if I hit shift and table, I get this table of values. I'm going to flip it around here. So I get this table of values, and the nice thing about this table of values is I can start to see, let's see if I can get it to show up better. Does not want to show up in that mode. So I guess we're going to have to go back to this mode. So I can start seeing on my calculator, it's not as easy on yours, but since I'm on an iPad here, you can start to see values. So I see that 1, when I did 1, it was 324. Remember, we just subbed in 1 on part B. When I sub in a 2, I get 512. Notice 0 is 0. -1, I couldn't cut out negatives because I can't have negative volumes. So the x is the square that I'm cutting out, the length of the side of the square, and the y, remember, is volume. So you can see that the numbers are getting bigger. They get up to 588, and then they start going back down. And notice at 10, they go back down to 0. So that kind of helps me with my window. Notice my x's, I only need to go a little bit past 10 since that's my domain, but my y values are pretty large. So if I just tried to graph this on a normal graph, I'm not going to see very much. So I'm going to have to change the window. So again, I'm going to make my x maximum maybe go to 15. Maybe I want to go to 20 because I know that I have 20 inches for my cardboard. You could do that. My y max, when we looked at that table, we knew it was up to 588, so I'm going to go to 600. And when I do this, I get a graph that looks like this. And down here, it's touching down here at 10. That's that domain. Notice it's 0 and 10 because I want the volume to be positive. But again, I can't cut out too much even though it continues on. So that's what we're going to kind of sketch here. So we're going to sketch that I went out here to 15 or 20. I went up here to 600. And then we're just going to sketch what this looks like. So it comes up, comes down, and then bounces back up. So that's the expectation of what I'm going to want you to sketch. Okay. So then it's going to ask you to find the maximum point. So on the graphing calculator, remember you're going to hit second and then trace or calculate. We're going to calculate a maximum, so number 4. And then you're going to go left of the maximum. The maximum is somewhere here around 3 or 4. So left of it and hit enter. Then you're going to go right of it and hit enter. And then it's going to ask you to guess. You're going to hit enter. And then it says the maximum is at 3.33 and then 592.59. Okay. So that would be my maximum point. So 3.33, comma, 592.59. Desmos will do that as well, and I'll show you on Desmos on the next one, so I'll show you both of them. So then the question says, what size square should be cut to maximize the volume? How am I going to get up here to the max? What's the x value? Remember, x is the size of the square. So that would be 3.33, and then give a label. This would be 3.33 inches. And then what's the maximum volume? Well, remember that x is the size of the square. The volume was the y value. That's v of x. So that's y. So that's up here. That's 592.59. And then remember, it's going to be inches cubed. Length times width times height would be a third dimension, cubic dimension there. Okay, because you're doing 3 dimensions. So notice that wasn't in the table. It went up to 588 in the table, but the maximum was actually at 592.59. Okay, so using that calculator to help us out, you can use that Chromebook app this year, okay, or if you have a graphing calculator, getting familiar with that. Again, I'll show you Desmos on the next ones. So example 2. David has available 400 yards of fencing, and he wants to enclose a rectangular area. So I have a rectangle here. So I want to express the area of the rectangle as a function of the width x of the rectangle. So I want to figure out where I'm going to put x. Well, x is the width. So width is on the left and on the right there. So that's x. So I need to figure out, again, if I'm expressing area, capital A, as a function of x, then I'm talking about a of x. Area is a function of x. That means that everything after that should only have an x in it. Can't have anything else. So remember that area is length times width. So I know the width is x, but I need to figure out the length. Okay, so the way that we can do that to figure out the length is, remember, I'm just going to put L's for now. So I know to figure out the length, I have 400 total yards of fencing. Well, that's my perimeter. That's all the way around. So I know that I have an x plus another x plus an L plus another L, and that's got to equal 400 because I'm just adding up my 4 sides. So I'm literally going x plus L plus x plus L. That's kind of the idea, okay? So if I add those together, I get 2x's plus 2l's is equal to 400. But I need to figure out what L is, because I need to figure out what L is in terms of x, so I can use it in that equation for part A. So I'm going to solve for L. So I'm going to subtract 2x. So 2L is equal to 400 minus 2x. And then I'm going to divide everything by 2. So when I divide by 2, 400 divided by 2 is going to be 200. And then negative 2x divided by 2 is going to be minus x. So my length is equal to 200 minus x, which should make sense, because if I have 400 to go all the way around, I only have 200 to go halfway around. So 200 minus whatever my width is would give me, whatever that x value is, would give me a total of 200, or it would give me my length. So my area, again, is length times width. So 200 minus x times my width of x. And I just like to put that monomial up front. If you want to distribute that out, you can. If we were to distribute it out, you would get 200x minus x squared. We didn't distribute it on the first one, but you could if you wanted to. But the one thing I want you to notice here is that it's a quadratic. It's going to be a parabola, okay, because it's going to be squared. The last one was a cubic. It was 3 dimensions. Area is 2-dimensional. So 3 dimensions is a cubic function, so that's why we had the 2 terms. Okay, area is 2-dimensional, so it's going to be a quadratic. So we're going to sketch a graph of this. So again, we're going to put down our x and y axis. We're going to label it x and a of x. And again, you're going to be expected to give whatever window you're using. So I'll use Desmos this time. So I'm going to take all these other ones off that we were using in the last section. So I'm going to use y instead of a. So y equals x times 200 minus x. Now I will tell you that Desmos has the same issue as the calculator. You have to have a good window. So remember, you can go up here and you can duplicate it and then make a table and start seeing some values here. If you wanted to start picking values for x, you could sub them in pretty easily. You can try to zoom in and zoom out on your graphing or on your Chromebook, but it's still not very pretty here. Okay, we want to get a good window. I'm not going to accept a window like that. So what you can do is you can think about what's going on here. What is the possible length that it could be? What's the possible width that it could be? So I'm going to take up here and go to this little wrench up here in the top right corner, and I'm going to change my x-axis from -10, and I know that I only have 400 yards of fencing, so I'm just going to go to 400. And then my y-axis, I can keep it at -10 just to have some negatives, but I have to think about what would be my maximum area. You'll notice we're already up to 784. I zoomed out a little bit and it's above 800. So maybe I start with 1,000, doesn't show up, so I backspace it. Maybe I try 2,000, still not big enough. Maybe I try 5,000. Okay, remember area is length times width, so I just keep trying different things until I'm starting to see that full parabola. So maybe 10,000, and if we look, we do get that. And then you can again zoom out a little bit if you want. That's the nice thing about Desmos with your Chromebooks, is you can pinch a little bit. So notice it really goes from 0 to 200 is where it's touching over here. So I really only needed to go up to about 250. I didn't have to go to 400. But then up here at 1,000, it does look like it's touching at 1,000. So I needed to go at least to that much. So I'm going to put that. So I'm going to say about 250 here was probably sufficient, and then 10,000 up here. So you are going to be expected to get that window. So then my shape is just a parabola. Again, it was touching, remember, at about 200 there. That's not a great parabola. One's a little better. So there's the sketch of my graph. So then it's going to ask you to find the maximum point. So once you get the equation and you're able to get the graph to show up, the maximum is just right up here. That's the nice thing about Desmos, so you can just click on it. So 100, 10,000, excuse me. So my maximum is 100, 10,000, and I'm not going to put the comma in the 10,000. So it says, what should the dimensions be? So we're going to be careful there. The dimensions be. Dimensions are a length times a width. Okay, so remember that this first 100, that's the x value, which was the width. And remember that this y value, That's going to be the area. Okay, that was A of x. And we look back at our graph, we see that x is going to be the width. We look back up at that sketch, and y is the area. So I know that the width is 100. So the width would be 100, and if we look back, we were in yards. So I need to find the length. And I can use either an x or I can use the word by. So my length, remember, if we go back here, my length we found to be 200 minus x. So all I'm going to do is I'm going to take 200 and subtract off that x, because if x is 100, then I know that 200 minus 100 is 100. So it actually ends up being the same thing. So my length is 100. It's not always going to be that. So you want to make sure you're finding that correct dimension there. So my dimensions would be 100 yards by 100 yards in this case. So yes, it ends up being a square. And it said rectangle, but remember squares are rectangles. Okay, so what's the maximum area? The maximum area is going to be that y value, so I'm going to put that in there. So it would be 10,000 yards, and this is area. Area is two-dimensional, so 10,000 yards squared. Also, guys, if you were to take this up here and multiply 100 by 100, you get 10,000. Remember, if you multiply length times width, you should be getting area. Okay, last one. This one's a little different, similar yet different. So Beth has 400 feet of fencing. So we're looking at that 400 feet of fencing here that she has. So 400 feet of fencing are available, but now the difference is here, she wants to enclose a rectangular field. But one side of that field is going to lie along the river. So I put my river in blue up here. So my river is up here. So that she only has to enclose 3 sides. So I want to express area of the rectangle as a function of x, so that only we're only worried about the 3 sides with the 400 feet of fencing. And it says where x is the length of the side parallel to the river. You can do it the other way. This is the easier way to do it, in my opinion. So if we want to find area, again, area is length times width. Well, we have the length this time. So area in terms of x, make sure you have good notation as a function of x. Okay, so we have to put that x there. So our length is x, but we need our width. So again, we have 400. This time we have 400 feet. So if we think about what we have, we don't know the width, and there's 2 of them. So if we figure out we have to put fencing around these 3 sides, we have a width plus x. Now, what we're trying to do is we're trying to solve for w. Okay, we've got to figure out what w is so that I can use it. So I have 400 equals 2w plus x, so I'm solving for w. So I'm going to subtract the x. So I get 400 minus x is equal to 2w, and then I'm going to divide by 2. So when I do that, you have a couple options, okay? You can say it's 400 minus x divided by 2, because that's what it is, or you can divide those. 400 divided by 2 is 200, minus you have a 1 divided by 2, which is 0.5 or 1/2 x. So you could do it either way. Okay, all of those would be equal. So you can use any of those. So to find the area, again, it's length. We know x is the length, but width, I'm going to use 200 minus 0.5x. That's what I'm going to use. Again, if we were to multiply those together, okay, we would get 200x minus 0.5x squared. Again, it's area. So remember, area is two-dimensional, so we get that quadratic there again. So we're going to sketch a graph. Not a very straight line there. Try again. We're going to label it. So x, again, is the side across from the river. The y-axis is a of x. We're going to have to give our window. So I'm going to go back to Desmos again. It's probably what most of you prefer. So it's x, and then it's 200 minus 0.5. So I don't have much to change, so it's just going to be easier to use Desmos. And then it's still giving me the other one. So I'm going to take that one off, and then I'm going to copy it and then create the table again. So you'll notice that the parabola all of a sudden got bigger. So my former window is not going to work here. You can see that I have a good start to it, but I'm going to go back up here to my wrench. And again, I'm going to take my X. It's really close. I'm going to go a little bit more than the 400. So I'm going to go to 450. So notice now that I can see where it's crossing. It is crossing at 400. Okay, but I need more on the Y's. Again, Y is my area. And when you take 100 times 100, remember, we got 10,000. So this can get pretty big. Okay, so I might try 15,000. Okay, 15,000 is not quite big enough, so I'm going to go back and try something else. Again, if you're trying to zoom in and out or using any zoom fits on your graphing calculator, probably not the best way to do it. So we're pretty close there, just a little bit over 20,000, but 20,000 again is where we're going to find that top part. So we want to be able to see all the important aspects here of the graph. So again, I'm going to label here. So this would be, I might go up to 500, 450. I could use 450. I think that's what I actually did. So 450 here. And then if we went up to 20,000, we're going to be right at the top. So again, we have our parabola opening down. If we wanted to talk about the domain of this one, it would go from 0 to 400. So X is an element of 0 to 400. Going back to the last one, it would be from 0 to 200 because that's where it touched here was 200. Okay, so we could, if we were asked to find domains here, we could do that as well. Okay, so then it says find the maximum point. So that's where we're going to, on Desmos, we're just going to look at that top point there. So I clicked on it earlier, so 200 and then 20,000. If you're using the graphing calculator, then you would do second calculate the maximum. Left bound, right bound, and then intersect. So again, the dimensions, this one's a little trickier here. We want to find dimensions. Remember that this is the side, this 200 was the X value. That's the side across from the river. So remember the side across from the river is the length. So the length is 200. And I believe this was in feet. So that is our length, but our width is not 200. Okay, this is not a square anymore. So remember for our length, if we go back up here, it was 200 minus a half times X is how we found the width. So that's how we're going to find the width here. So we're using that information. So the width is 200 minus 0.5x. So to find my width, I'm going to take 200 minus 0.5, and my x value was 200. So my width is 200, a half of 200 is 100, so my width is 100. So length is 200 feet, width is 100 feet. So again, if we think about that rectangle, I'm going to draw a picture here of it again. So remember, this was the side on the river. So this would be 200, that was my length, 200 feet. My width is 100 feet apiece. And notice that that adds up to 400. Just like the last one was 100 all the way around, and 100 all the way around would add up to 400 as well. Okay. Also, area, remember area is this Y value. So the area is 20,000 square feet. Again, length times width would be two-dimensional. But guys, notice if you take 200 times 100, you get 20,000. So another way that you could find the dimensions is if you know that this first number is x and the second number is a of x, you know that area equals length times width. So if the area is 20,000 and you know that x was the length, which is 200 times the width, you could divide by 200 and you could find that your width would then be 100. And that would work on the last one as well. So there's different ways of finding the length and the width. Okay, so that's all we're going to do for this section, section 1.10. So the assignment for this is a Schoology assignment. Make sure that you're able to do those problems without using your notes. So I did try to shorten it a little bit for this year. Otherwise, I'm going to actually give another one of just some practice problems of what I took off. So making sure that you're trying to think through just the process of what you've got to do here. Things are making sense to you. And if you need any help, I'm definitely willing to help you out on some of those work days or optional Google Meets. So don't hesitate to join those and let me help you out. Or you can send me an email. We can set up a time for sure. Hope you guys have a great day.